Hello all and welcome to the Web Application Hacking course. My name is Alex Thomas and I have been a penetration tester for 3 years now. I got my bachelor's degree in cyber operations from Dakota State University, and I also got my master's degree from there as well. Some of my hobbies include messing around with robotics, trying to learn machine learning. I also do capture the flags. Um, if you haven't done that, I would recommend going to ctftime.org. They have a whole listing of those events there. It only takes like 20 seconds to actually sign up for one. It's great experience for you. Um, so in this course, we will first start off by setting up our vulnerable lab. After that, we will go into burp suit, and then we will start getting more hands-on after that. Um, we will start doing the actual vulnerabilities. Um, each of these lessons will have a quiz associated with it that will help you um, find these vulnerabilities in the wild. Um, So we see here that we will go over insecure redirects first, and then we will go over directory traversals, followed by SQL injections, and then cross-site scripting, and then cross-site request forgery, and finally we will end with XML external entities. There are also 2 assignments in this course, which will require you to download a ISO from the website's VulnHub, and basically you will be required to hack that machine. Um, VulnHub is a little bit more realistic compared to these practice applications. Um, so those assignments are a great opportunity to get some experience. So that's it. I hope to see you guys in the course. Hey guys, today we are going to talk about OWASP broken web applications. This is a vulnerable machine created by OWASP, and this vulnerable application basically has a series of other vulnerable applications installed on it. So if we go to the OWASP website, and then we can navigate to the right hand side under quick download, and then we just click the download button, which will take us to SourceForge. And on here, we just click download the latest version, and then this will download a 7-zip file. I already have it, so I'm going to cancel this. And once you have this 7-zip file, you can go ahead and open it, and then you will be presented with a vulnerable machine. You will need to open this in VirtualBox or VMware Fusion if you're on Mac, or any other virtual application that can open these type of things. So once we have that, we can go ahead and open the virtual machine, and we can log in with the username of root, and the password is OWASPVWA. And once we're logged in, we just want to check our IP address, and we will need to note this IP address so that we can connect to it. So I already have my Kali instance running, and it is on the same network as this vulnerable machine. So if I log in here, and I'm already navigated to the vulnerable machine's IP address right here. So we can see that this has several other vulnerable web apps running on it. And this just makes it a lot easier so that we don't have to go around downloading all of these other vulnerable web apps. We just have them all on one machine, which will make it easier for us when we are testing it. So now that you have OWASP BWA installed, we are ready to start hacking. Hey guys, in this video we are going to go over Burp Suite. Burp Suite is a tool that basically every pen tester uses. It is pretty much the only tool that I use when I'm doing web application pen testing. So we can open up Burp Suite by clicking it here, and this will open Burp. I'm not going to update here, and you can save a project for later so you can reference things. I'm just going to create a temporary project and start Burp. Now this will listen on port 8080, so we will need to configure our web browser to forward traffic to port 8080 so that Burp can intercept it. So I'm using Firefox, and in Firefox we can go to Preferences, Advanced Network, Settings, and then it's set to no proxy. We want manual proxy, set it to the local host IP and port 8080. You can click OK, and now all traffic will be sent to Burp. So if I just try to open up one of these vulnerable web apps here, we will see that it isn't loading up right away. That's because the traffic has been intercepted through Burp Suite. So we can go ahead and forward this, which will cause the page to load. And if we click on anything else, the same thing, we will have to keep on forwarding request. So I like to turn off the interceptor. This will make it so you can click through the websites and stuff without having to click forward every single time. You can see your request in the HTTP history tab. And to see your most recent request, just click here and it'll show your most recent one. So if I go change password, cool. Now in this tab, if you want to play around with a request, for instance, this allows you to search and it produces some results here. And I can send this to the repeater, which will allow me to play around with this request. So we see here on the right, we have the request. It's a GET request. It's being sent to this address. It has some parameters, title, which is equal to K, which is what we typed into the text box, and an action parameter, which is equal to text. We have the vulnerable machine IP right here, our browser user agents, and some other header information. So we can go ahead and send this request, and Burp will capture the server's response. We have the server's response headers right here, and we have the response here. We can render this, which is display something similar to what we saw in Firefox, which is our search. So we can play around with this request, like I said earlier, and let's say I want to search for the title C. And this will go ahead and send that request and capture the response. We also have some other useful tabs: the intruder tab, the scanner tab, which will allow you to scan the application for vulnerabilities. Spider will spider the application to find links. You have sequencer, decoder, comparer, and some other tabs. I typically stick with the proxy tab in the HTTP history. I'm typically clicking around the application, and I'm looking at the request in the HTTP history tab. Once I find something interesting, like a search or something where there's user supplied input, like we found right here, like we found right here, any user supplied input, I will generally create the request, and then I will send that request to the repeater so I can play around with that request to try to find any vulnerabilities. I also use the intruder tab sometimes to try to automate some task, such as dumping a database. So that is the basics of Burp. That's pretty much all you will need to know for now, and then we will learn as you go. Hey guys, in today's video we are going to talk about insecure redirects. So basically this will allow us to hijack a redirect so that it will send it to a malicious domain instead of the intended domain. So you'll see what I mean here in a second. So let's log into the BWAP application, bbug, then log in. Then we can go to the insecure redirect here. It's right here, unvalidated redirects and forwards. And then if we see here, we have a drop down, we have a list of websites that we can be redirected to. So I'm just going to leave it on the blog and hit beam. And then we can see that it sends us to some blogspot website. So basically what is happening is we click beam and then we're being redirected to this website. So we can hijack this in order to redirect us to a malicious page instead. And we'll see what I mean here. So if I look at in burp in the history, we can see my request that I previously made, and we see here is that same URL, that blogspot URL that we are being redirected to. So there it is. So I'm going to send this to the repeater just so I can play around with it. I'm going to send the request, going to hit follow redirect, and then we can see here that it's the same page. So everything's working. Just going to go back. So basically what we are going to do as the attacker is we will replace the URL parameter to our own malicious parameter. So I'm just going to use google.com. You would replace this with whatever your malicious site is. This should be some sort of phishing site, some sort of exploit site that will run a exploit kit, or some sort of download file or whatever you want it to be. So I'm just going to use google.com. And if I hit go, I should be redirected to Google. I'm just following all the redirects. And then we see that it seems to be working. We are redirected to google.com. So if I go back here, I'm just going to copy this into the actual URL. This is what you would send the target. So the actual redirect is this. Copy that. So when you click this beam button, it is actually just sending you to this URL, which has the same results right here. And we see that it has the URL parameter right here, and it's being sent to this domain. So if I hit enter, I should be redirected, and I can actually change that, just like we did before in burp. Change this to Google, or in your case it'd be whatever your domain is that you want them to be sent to. And you can see here that we are redirected to Google. So why is this a issue? It is mainly because, let's say that instead of this domain, this says facebook.com and it's redirecting you to LinkedIn. when a user sees facebook.com, they're going to trust that domain. So you can take advantage of that by sending them facebook.com that will then forward them to whatever your malicious page is. Hey guys, in today's video we are going to talk about directory traversal. So this vulnerability allows us to read or to write to files on a system. So for example, let's say we have a website that will allow us to download a executable file. We can sometimes play around with the download name in order to download arbitrary files from the system. So if we go to the BWAP application, and then we go to, scroll down a little bit, we should see directory traversal right here. And then we can see here that it has some sort of message.txt, which is a file on the vulnerable server. So if I just do this, it says file does not exist. So first of all, let me talk about what that is. So in Linux, we can go back directories by typing in this right here. And basically this means change directory // means go back one directory. So if we look here, this means print working directory. We're in /root/desktop. So if I type cd .. I should be put into the root directory. So basically what this is doing right here is we put in .. so it is going back one directory. So we can abuse this to read sensitive files on this system if it is vulnerable. So just type in a bunch of these, and basically I'm just trying to get to the very beginning of this file system. And then we can go to /etc/password, and this should bring up a list of all users that are on the system here. So we can see that we can read sensitive files that are on this system. Hey guys, in this video we are going to go over the importance of reading the source code. So I'm actually already logged in. Let me just log out real quick so you actually see what I would see, or what you would see when you first come in. If it does it, it's not logging me out. Oh, that's weird. So when you first log in, you are going to see a login page, and then the username is guest and the password is guest. So after that, you will be forwarded to this page, and then we are going to go over here and click on the improper error handling. Or not that, I'm sorry. We're going to click on the code quality, and then we will click discover clues in the HTML. So basically what we are going to do is we're going to look at the source code, and then we are going to try to find clues that are hidden in the comment fields. So you may be thinking that This never happens. No one ever leaves sensitive stuff hidden in as a comment. But that actually isn't true. Um, so in this case, they've actually we can see the comments are easy to find because they're green. Um, this is a comment tag right here, and that's the ending tag. So we can see that it says fix me admin password. So that's actually the username and the password to log in to this exercise. So admin password, or PW. It says congrats. So like stuff like this actually does happen in the real world. I've normally I will find error messages um, that are outputted as comments, and then those error messages can most of the time lead to something bigger. One time I actually found SINs hidden as a comment, which was really disturbing because who would put their social security number um, as a comment in the source code? But basically, the thing to note from this is when you have found nothing else, always look at the source code and just start reading the comments that the developers left because you might be able to find something useful in there. Hi guys, in this video we are going to go over basic union-based SQL injection. So first, let's go to the BWAP application, and then let's click on the first SQL injection lab. Click hack, and before we get started, I should probably explain the basics of a database structure. So you have a database name, and then under each database there are a series of tables, and each table holds a series of columns. So for example, let's say we have the database named Facebook. Facebook, the Facebook database probably has a table named user, which has the columns of email and password. So that's the basics of a database structure. Now we can move forward to the actual hacking part. So first we want to generate a error message. This can be done by doing a double quotes, and if that doesn't work, we can do a single quote, which the single quote generates a error message right here. Awesome. So now that I know that that's vulnerable, and remember that we have burp suite running, I can go back to my burp and I can send this request to the repeater right here just to make sure that it's the correct one. I see the same error message. So now I'm going to comment out the rest of the SQL query by doing plus dash dash plus dash. So the plus just stands for a space, and the dash dash space dash is a comment. And if I go ahead and send this, we see that it works correctly. So the first thing that we have to do is we have to determine how many columns are being displayed on this page. So as I said earlier, the columns are held in each table. So in this case, there is a table name behind here, which probably has a column named title, release, character, and so forth. So we can try to guess how many columns there are by using a order by statement. So we're going to say order by 10, which is basically saying, are there 10 columns? And we get unknown column 10, so there's not 10 columns. And if I do 7, then we see that it displays correctly. And if I do 8, we see that there's not 8 columns, so there must be 7 columns because it works correctly on this page. So now we can use a union statement, which will allow us to have 2 SQL queries. And we put the number of columns there. And remember that the pluses stand for a space. So if we do this, we see that it displays correctly. That's actually not what we want, so we need to error out this first SQL query so that it will show our SQL query. So we errored out the first query by putting a minus sign there, and we see we get these strange numbers on the page. These numbers basically represent the columns and where they are being displayed on the page. So for example, I can change this to hello and the third column to world, and it will display hello world in there instead of the numbers. So if I were to, so the first thing that we want is the database name. Like I said, we need the database name, we need the table names, and we need the column names so that we can extract the credentials. So we need the database name. We can get that pretty easily just by typing database. And we see the database name shows up here. It's called BWAP. So the database name is called BWAP. So next we need the table names that are from the BWAP database. And we can get the table names from the information schema database, which is located in every database. So from information schema dot tables, which is just a database that has a list of all of the table names, and we're getting the table names column right here from this database. And table name, not table names, sorry. So we see that there's a bunch of table names, too many to scroll through. So we need to narrow this down to only our database, which can be done by doing where table schema equals database, which is our database name. Go. I misspelled that. Huh. Misspelling all kinds of things here. Okay. I misspelled schema and I misspelled database. But here we go. So here's the complete SQL query to gather the table names. So we have 4 different table names. The interesting one looks like this users table. So now we can simply add and table name equals users, and then now we just want the column name from the information schema.columns table, which will hold all of the column names, and we're gathering the column name back where the database equals bwap and the table name equals users. Got a plus right there. And here we go. Here are the column names for the users table. So now we can go ahead and extract all of the usernames and passwords. So instead of displaying the column name, I'm going to use a concat function. Then we're going to combine the login column with the password column. We're getting that from the users table. So here we have 3 users, AIM, B, and test, and we have the password hash right here. So the next steps after this would be cracking this password hash, which I will leave up to you guys. Hey guys, in today's video we are going to talk about reflected XSS. Reflected XSS is non-persistent, and the attack payload is generally present in the URL as a parameter value. So in the same vulnerable, machine, we can navigate to the Wacko Picko application. And this is a vulnerable application that will allow us to practice reflected XSS attacks. So generally when you are looking for XSS, you will try to fill out all of these text boxes, and any text box that you see is potentially vulnerable to XSS depending on how the text is reflected back on the page. So I happen to know that the search box is vulnerable, so I'm just going to start there. So normally you would search just to see what would happen. We see that our text is being reflected back on the page. So this is normally a good sign that there might be XSS. So as I said before, reflected XSS, the parameters are, or the attack payload is typically found in as a parameter value in the URL, and we can see that right here. So if I were to search for C, you can see it changes down there. So we can easily check for XSS just by typing in a script, and if it renders, that means that XSS is valid, that it has found XSS. And if it doesn't render, that means that they are properly sanitizing inputs and that XSS is not possible. So if we see here, we see nothing, but if we look at the page source, we are looking for that tag of x3, and we see right here that it is being rendered perfectly. So this is a fairly good indication that XSS is possible. So let's go ahead and switch that to a script tag so that we can insert some JavaScript. And I'm just going to open a alert box and just type win in here. And we see that XSS is possible. So typically a attacker will try to steal the user's token, and this is as easy as typing document.cookie. And we see we have my cookie here. I'm not logged in, so there's no actual login cookie. Well, an active one for this. But generally the attacker will send this cookie off to his website so that he can then log in as this user. So that was basic reflected XSS. All we have to do is copy this URL and send it to someone, and if they open it, then we can see their cookie in a alert box. Hi guys, in this video we are going to go over stored XSS. Stored XSS is different from reflected XSS because it is persistent. It is persistent meaning that it will be rendered on the page every single time you visit that page. You won't have to send a specially crafted URL. So if we go to the Purgia application, we can see that this is a vulnerable application that allows us to comment on a picture. So if we comment here, we can see that this comment will persist on the page. So this is a good indication that we will want to test for stored XSS. So I can test for that by simply saying hello and then our script tag, and we can check to see if this got rendered by searching for the x3 tag, which is right here. So we know that this is vulnerable. Now all we have to do is insert some malicious JavaScript, and in this case it will just be a alert box displaying our cookie. Awesome. So now every time we visit this page, we will see a alert box. So that's why stored XSS is so much more dangerous than reflected XSS, because this can be used to target anyone. While stored XSS, they will have to click, while reflected XSS, they will have to click on a link, a malicious link. Stored XSS, all they have to do is visit a page. Hey guys, in this video we are going to go over cross-site request forgery, also known as CSRF or CSRF. So if we go to the Rails Code application, we can log in and we can get the credentials here, then click I understand. Normally you would try to hack your way in, but we're just using this for a specific exercise. So admin user 234, and we are logged in. So next we can go to the admin tab, which will allow us to edit users, and we can edit the email, name, and the password, make them admin, and whatnot. So if I just want to change this user's password, I can do testing, and I can submit it. So what a malicious attacker can do is they can try to trick the victim into submitting the same request, except for we can put in our own password. So first, let's capture this request using Burp Suite right here, and just going to send this again, testing, submit that. And if I go here, send this to the repeater. And just to validate, we get the message success. So this updated the password with, we see here, testing, and here's the confirmed testing. Here's the email and all of the other users' information. So we see that we have a token here, which is probably used to authenticate the user, which, if this is true, this will prevent the CSRF vulnerability. So I'm just going to test this by removing this and see if it still allows me to update the user's password. And we see here it does. Awesome. So I'm also just going to remove this because I don't need it. We can see that that still works. But if I were to try to delete this part, I get an error. So I need that parameter. Cool. So let's send this to the decoder because I see that it's been encoded. So we can decode as URL, and then we get the actual parameters and their values. Looks like I missed a little bit here. Cool. So we see method equals post, user bracket email equals Jack at Metacorp, first name equals Jack, last name, password, confirmation if the user's admin. So we need to create our own HTML form that has these same values in it. And I've already done that. So here, just have an HTML. I have the form tag, a name. This is where it is being posted to, and it is a post request. So I can get that information from right here in the request. We see the host address and the path right there. And we can see that it is a post request, which is the same information that's right here. So next we have to fill out the form information. So we see I have the method, the user email, first name, last name, and then our password. This is our malicious password, the one that we want it to be changed to. And these fields correspond to the actual request fields right here. So user email, first name, that's the same thing right here. User email, first name. So what happens is if we can get a victim to navigate to this URL, and if they send a post request, it will use the same cookies as this Ruby application, and it will send a post request to change this user's password. And this happens because the Rails Goat user is logged in and it is using the same browser that this application is loaded in. So when I click execute, it will send a post request to the Rails application asking to change the password, and it will use the admin's cookie to do that. So if we do that right here, we can see message success. And another thing to note is that this doesn't require the user to actually click this button right here. We can automate that using JavaScript. So if I were to put some JavaScript at the bottom here, I can submit this form without having the user click on it. And document.csrf, which is the form name, and then .submit to submit the form. And this will automatically submit this JavaScript form. I put a comma here. That should be a dot. Cool. So it automatically changes the user's password whenever a victim navigates to this web page. So if I try to log in as that other user here, you can see that the password was actually changed. And so we see that the password was changed. So basically what we did was we exploited CSRF vulnerability in order to submit a form that changed the Jack user's password. And this can be accomplished simply by getting a logged in user to navigate to a malicious web page. Hey guys, in this video we are going to go over XML external entity attacks, also known as XXE. We will be using this attack to read a local file on the victim computer. So if we go to the OWASP application here, then we go to Other and XML external entity injection, and here we have a XML validator. So if you see here, we have a example. Just gonna copy this, and when I hit validate XML, we see that it parses the words hello world. So what I can do is I can try to generate a error message to see if XXE is possible, and we can do that by typing in this, and we see here we get a error message. So that is just going to signal that XXE might be possible. So we are going to try to open up the password file, and in order to do this we just need type in XML version equals 1.0, and we will doc type, and we can give it a random name. Then our external entity, and here is where we put the file. This is the Linux password file. And now I have to give it a name. So we have a doc type foo with the entity XXE. This is basically a variable that holds the password file. And then we can print the contents of the XXE entity or variable using this command. And that should have a semicolon at the end. So if everything is typed in correctly, we should see the password file. And as we do right here. So just a recap, we use the XXE vulnerability to create a entity named XXE that contained the password file, and then we were able to print that variable which contained the password file, and we were able to print that to the screen.